Okay, so let's talk about these radicals with variables for a little bit. I'm just going to go through a couple of the problems on the homework and kind of just walk through them a little bit. Hopefully it'll make a little more sense, okay? So I'm going to look at number 2, actually. What you want to do when you're doing this is you kind of want to split it apart, okay? So let's talk about the cubed root of 16, and then we'll talk about the cubed root of y to the third, okay? So for 16, you want to make a factor tree. Remember that the index, which is 3, is telling you to look for groups of 3. So once I make my factor tree, I can see that there's going to be a group of 3 right here. So that whole group comes out as 1, 2, right? And then I'm left with, that's hard to see, sorry. And then I'm left with 1, 2 that's inside the radical. That's the number part. Now I'm going to go over here to the y's. What y cubed means is that I have y times y times y. So it kind of works like a factor tree in that I'm still looking for groups of 3 because that's what the index, this little number, tells me. But this one's kind of nice because I have one group of 3 with no leftovers. So that y then comes outside of the radical with nothing left, okay? And so now I'm going to put this whole thing together, and I'm going to get 2y on the outside, and then I'm going to have the cubed root of 2 that is my leftover, all right? So if you can kind of separate them, and like for number 3, you could separate this into 18, and then do x squared, and then do y cubed. Kind of separate them out and do each one sort of separately, looking for the groups, okay? Let's look at number 6 and talk about what happens on this one. So this 2 is just going to kind of hang out, and I'm going to put it in at the end, kind of what I did back here with this, okay? So I'm going to start with 24, and I'm going to make a factor tree. I'm going to go 4 times 6, 2 times 2, 2 times 3, and then, of course, I've got my group of 3 here. So I've got that 2 that comes outside, and I'm actually going to multiply this 2 by the 2 that's already here, and I'm going to have a 4. That's where that comes in. And then I'm left with a 3 on the inside, okay? So that's the numbers. Now I'm going to look at, that was the 24. Now I'm going to look at the M4, and I'm going to do the same thing, okay? So the cubed root of M4 means that I have 1, 2, 3, 4 M's, and I'm looking for a group of 3. Well, there's 3, which means that I have 1 M outside because I had one group, but I still have this little guy that's left inside. So it's M and then cubed root of 1 M left over. Now I'm going to do the same thing with the N5. Okay, so that means that I have 5 N's, 1, 2, 3, 4, 5. I'm looking for a group of 3, which I have 1, but this time I have 2 left over. So that makes this N cubed root of N squared, because I have 2 of them left over, okay? So now I need to put all of these together. So I'm going to take all of the things that are outside, okay? So I have a 4, an M, and an N on the outside. And then what do I have all of my leftovers inside? Well, here I have a 3. Here I have 1 M, and up here I have an N squared. So this is my final simplification here, the 4mn, and then cubed root of 3mn squared, okay? Let's talk about what happens when you have a fraction. So let's look at, how about the 9 one? So what you can do if you want to, if this makes more sense to you, is split it up into 9, square root of 9a5 over the square root of 64b4. And then your answer is just going to be a fraction with the top and the bottom. Or you can leave it as 1 and simplify within. It doesn't really matter. That one's not going to be too terribly difficult, so I'll let you take it from here. But let's look at 14, because this one might be a little more difficult. Okay, so I'm going to kind of split this up into pieces again. I'm going to look at the P5 as 1, the Q3 as 2, and then the 40 as a third. And again, I'm looking for groups of 3, okay? So if I have 5 P's, 1, 2, 3, 4, 5, and I have, let's see, I'm looking for a group of 3, and then I have 2 left over. So I would have 1 p on the outside, and I would have 2 p's or a p squared on the inside, okay? And then if I do the q's, let's see, I have 1, 2, 3 q's. That's just a straight up group of 3, so I have a q on the outside, nothing left on the inside. And then if I do the 40, let's do this color. And I make a factor tree for that. 8 times 5, 8 is 4 times 2, 4 is 2 times 2, and here's a group of 3 2's with a 5 left over. So I would have 2 cubed root of 5. Now again, I'm going to put all those together, but remember that this 2 cubed root of 5 was on the bottom of the fraction, okay? So when I put all this back together, let me pick a good color here. On the outside, I have a p and a q, and then I have the cubed root of p squared. And then in the denominator, I have 2 and then the cubed root of 5. So this would be one acceptable way to write this. Or you could do, let's see, pq over 2. And then you could do the cubed root of p squared over 5. That would also be an acceptable way to write that. These are 2 ways of writing the exact same thing. To be honest, it really does not matter how you decide to do it. If you want to do 2 fractions, 1, however you want to do it, okay? So 15 would be very much like this, and 13 would be very much like this as well. For the simplification. So hopefully that kind of helps you a little bit. If you still have questions or you're still struggling, please let me know. I'm happy to go over more, okay?